Hello, beautiful people. Today's lesson will be on factoring quadratic trinomials, and this will be part 1 of 2 on this topic. So we'll begin with a little bit of a review on vocabulary. First, let's break down these words: quadratic, trinomials. Well, trinomials, remember, that's a type of polynomial. And say you have this polynomial. Notice the polynomial has 4 terms. 1, 2, 3, 4. Well, as it turns out, each of these terms has a different name. This one is called the cubic term. This one is called the quadratic term. This one is our linear term. And this one is our constant. What makes the difference between each of these is the exponent. So notice, cubic goes with the exponent of 3. Quadratic means you have an exponent of 2. Linear means you have an exponent of 1. Remember that 1 as an exponent is always going to be invisible. And the constant, that's just your number with no variable. Also remember that a polynomial can be named based off the number of terms. We have monomial, which means we're dealing with only one term. Some examples of monomials would be 5x, that would be a linear monomial, or 6x squared, that would be a quadratic monomial, or for example 8, that's just a constant. We also have binomials. Remember, binomial means you have 2 terms. Notice the prefix bi. Some examples of binomials would be 5x plus 1, or x squared minus 25, or 3x squared plus 2x. We can also have trinomials, and if you were to take a wild guess, how many terms do you think a trinomial has? The word tri lets you know that we're talking about 3. An example of a quadratic trinomial would be x squared plus 8x plus 15, or another one would be 6x squared minus x minus 12. And that brings us to today's lesson. Today we'll be learning how to factor quadratic trinomials. And specifically, we'll be learning how to factor trinomials of this form. These are a little bit more complex, and that'll be in the next lesson. Before we get there, though, let me introduce the standard form of a quadratic expression. It looks like this: ax squared plus bx plus c, where a, b, and c stand for numbers. For example, with x squared plus 8x plus 15, our a would be the coefficient of the quadratic term. And notice, since we don't see a number in front of the x squared, we know there's an invisible 1 there. So in this case, a is 1. Our b would be the coefficient of the linear term. This time we do see a number, and we can see that our b is 8. Finally, c would be our constant term, and in this case, that would be this number at the end here, which is just 15. If we look at our second example, 6x squared minus x minus 12, in this case our a would be 6. Our b would be the coefficient in here. Notice that we see a negative and no number, so that lets us know that our coefficient is -1, and that's our b. And finally, our c is this last number in the end here, or the constant, -12. In this video, we'll only learn how to factor quadratics of a specific type when a is 1, meaning our quadratic has this format: x squared plus bx plus c. And here's a step-by-step on how to do this. First, we'll list the factors of c. Then from this list, we'll choose the pair of factors that add up to b. And finally, we'll write it in factored form. Let's see what all that mumbo-jumbo means. Let's go back to our expression that we talked about earlier, x squared plus 8x plus 15. The first step in our step-by-step says to list the factors of c. In this case, c is 15. The factors of 15 are 1 and 15, also 3 and 5, and those are the only factors of 15. Step 2 says to choose the pair of factors that add up to b. Notice our b in this case is 8. So our goal is to pick one of these pairs that once we add them, we will get 8. Now if we check, 1 plus 15 is 16, so that cannot be it. Remember, our goal is 8. If we check the second pair, 3 plus 5, that gives us 8, and that's what we wanted, so we have a winner. The next step is to write in factored form. What we do is we'll take these factors that we found and we'll put them in little binomials. So in factored form, our trinomial would be x plus 3 the 3 is coming from there, times x plus 5, the other factor that we found. And that would be our final answer. Now remember, factoring and foiling are opposites of each other. So to check if our answer is correct, we would have to FOIL. We have x plus 3 times x plus 5, and to FOIL it, we would multiply x times x, that's x squared, then x times 5, that's a positive 5x, then x times 3, that's plus 3x, and finally 3 times 5, that's plus 15. If we look at our polynomial here, we see that we have like terms. Our like terms being 5x and 3x. We can tell they're like terms because they have the same variable x and the x's have the same exponent, which is 1. We can combine them and get x squared plus 8x plus 15. And if we compare, this is exactly what we started off with. So we know we did it correct. Let's try it again. Here we have number 2, x squared plus 4x plus 3. Again, our first step is to list the factors of c. In this case, our c is 3. So the factors of 3 are 1 and 3. And that's it. Remember, 3 is a prime number, so it only has the factors of 1 and itself. Now, our second step is to choose the pair of factors that add up to b. In this case, our b is 4. That's our goal. And since our list is so short, we only have one pair of factors to try out. And when we add them, 1 plus 3, we see that we get 4, which is what we're looking for. That means that the factors that we were looking for are 1 and 3. And we're at our last step now, which is to write in factored form. So we write x plus 1 times x plus 3. Once again, we can check our answer, and we would do that by foiling. So x plus 1 times x plus 3. X times x, that gives us x squared. X times 3, that's plus 3x. 1 times x, that's just a 1x, but remember we don't write the 1. And 1 times 3, we get 3. Again, we can notice the like terms in the middle, 3x and x. And when we combine them, we get x squared plus 4x plus 3 as our final answer. Comparing this to our original, we see that they're exactly the same, and we know we factored correctly. I hope you're getting the hang of it so far. We'll do one more example of this type of question. These trinomials are the easiest kind to factor. Once again, we start by looking for the factors of c. That's 30 in this case. Remember, what we're looking for are all the pairs of numbers that when multiplied will give you 30. However, 30 is a little bit larger than the other numbers we've been working with, and 30 has a bit more factors. So I'm going to show you a trick that you can use to get all the factors. You start with the number 1. Well, 1 times 30 is 30. Then you check if 2 goes into 30, and it does. 2 times 15 is 30. Then we check the number 3. 3 goes into 30, that's 3 times 10. Then we check the number 4. 4 does not go into 30. And then we check the number 5. And we have 5 times 6. Notice the next number would be 6. However, 6 is already on the list. And that lets us know that we got all the factors of 30 once the numbers start repeating. What I mean by that is, since 6 is a factor, we'd have 6 times 5. We check 7, it doesn't go in. We check 8, doesn't go in. 9 doesn't go in, 10 goes in, that's 10 times 3. We check 11, it doesn't go in, 12 doesn't go in, 13 doesn't go in, 14 doesn't go in, 15 goes in, that's 15 times 2. And the point I'm trying to make here is that these factors are already accounted for. Notice we got them up here. So again, if you check for factors in order, starting with 1, 2, 3, and so on, once you get to a number, in this case, our number was 6. Once we got to 6, we noticed that 6 was already on the list, and we knew at that moment that we could stop checking for more factors. Moving on to our second step, we want to find the pair of factors that will add up to 17. So our goal is 17. We can start checking. 1 plus 30, that gives us 31. 2 plus 15, oh, there's our winner. That gives us 17. That's what we want. So when we write it in factored form, the numbers we'll use are 2 and 15. So we have x plus 2 times x plus 15. Once more, being the good mathematicians that we are, we'll check our work. And we'll check by distributing or foiling or expanding. Remember, all of those are synonyms. We have x times x, that gives us x squared. Then x times 15, that's a positive 15x. Now 2 times x, that's plus 2x, and 2 times 15, that's plus 30. We're looking for like terms here, and we see that 15x and 2x are like terms, so we can combine them, and we get x squared plus 17x plus 30. Comparing this to our original, we see that they're exactly the same, and that lets us know that we factored correctly. Now, you might be wondering why in our step-by-step, I put these words add up to in parentheses. And now our examples are going to start getting a little bit more interesting, a little bit trickier, and we'll see how the operation we're looking for is not always necessarily addition. You'll see what I'm talking about in just a moment. We'll begin once more with listing the factors of C. We'll start with the first step as usual, which is to list the factors of C. In this case, our C is negative 20. However, when we list the factors, we don't need to consider the signs, at least not yet. We'll go in order like we did with the last question, starting with the number 1. 1 goes into 20, that's 1 times 20. 2 also goes into 20, that's 2 times 10. We'll check the number 3. 3 does not go into 20. And then 4. 4 is a factor of 20. That'd be 4 times 5. Notice the next number we check is 5. However, 5 is already on our list, and that's what lets us know that we're done finding all the factors of 20. Second step is choose the pair of factors that add up to b. In this case, our b is negative 1. That's our goal. And if we look through our list, if we add 20 plus 1, we get 21. If we add 2 plus 10, we get 12. And if we add 4 plus 5, we get 9. None of those are negative 1. And here's where I want to clarify what these words add up to really mean. Add up to is a really loose term here, and really what I mean to say is combine, using the operations of addition and subtraction. So we went through our list of factors and we saw that adding the numbers in the pairs did not give us negative 1 for any of our options. Let's see what happens when we subtract the numbers instead. We can ignore the signs for a second. If we subtract 20 minus 1, we get 19. If we subtract 10 minus 2, we get 8. If we subtract 5 minus 4, we get 1. And now we're getting close to our goal. Remember, our goal is to choose the pair of factors that will combine to give us negative 1. And the fact that when we subtract 5 and 4, we get 1 lets us know that some combination of 4 and 5 will give us negative 1. Let's check the possible combinations. If we take 5 minus 4, we get 1, which is not what we want because we want a negative 1. However, if we subtract 4 minus 5, there's the negative 1 we're looking for. So we have a winner. Notice the signs here. Our 4 is positive and our 5 is negative. So let's be careful when we write our expression in factored form. We open up our parentheses. We can write our x in there, and the two numbers that go inside would be a positive 4 and a negative 5. You know what we're going to do next? That's right, we're going to check our answer. So x plus 4 times x minus 5. We'll distribute. We get x times x, which is x squared. Now x times negative 5, that's negative 5x. 4 times x, that gives us a positive 4x. And finally, 4 times negative 5, which is negative 20. By now, I'm hoping you expect that we'll get like terms here. And we do in the middle, negative 5 plus 4x. So we have x squared, and combining negative 5 plus 4 gives us negative 1. But remember that 1 is invisible. So we'll just write negative x and then the minus 20. If we compare this to our original, we'll see that they are exactly the same, which lets us know that our factoring was correct. We'll go to our next question. X squared plus 3x minus 18. First step, to list the factors of c. Our c in this case is negative 18, but once again, when we're listing the factors, we don't really need to consider the sign, not yet. So 1 goes into 18, 2 also goes into 18, that's 2 times 9, 3 also goes into 18, 3 times 6, 4 is not a factor of 18, 5 is not a factor of 18, and then we check the number 6, but 6 is already on our list, so we know we're done. Next thing is we need to figure out what our goal is. In this case, our b is 3, so our goal is to pick the numbers out of the list that when we combine them, we'll get 3. And remember, combining means either by adding them or by subtracting them. So let's check. If we add 1 and 18, we get 19. If we subtract 1 and 18, we'll get 17. Neither of these are 3, so that's not what we're looking for. Let's check 2 and 9. If we add 2 and 9, we get 11. If we subtract 2 and 9, we get 7. Neither of those are our goals, so let's keep checking. 3 and 6, if we add them, we get 9. If we subtract them, we get 3, and that's what we're looking for. So we found a winner. Now we have to figure out the signs. Let's check. 3 minus 6, that gives us negative 3. That's not what we want. However, 6 minus 3, that gives us the positive 3 that we're looking for. We'll open up our parentheses once more. We can write our x's inside, and the two numbers that we found are positive 6 and negative 3. So our final answer is x plus 6 times x minus 3. We'll check by foiling x plus 6 times x minus 3. And we have x times x, which is x squared. Now x times negative 3, that's negative 3x. 6 times x, that's a positive 6x. And then 6 times negative 3, that's a negative 18. We've got those like terms in the middle, there they are. When we combine them, we get x squared plus 3x minus 18. And that is exactly our original, so we factored correctly. Here's our last example for this lesson, x squared minus 8x plus 12. We'll list the factors of c, in this case 12. That's 1 times 12, also 2 times 6. We also have 3 times 4. The next number we'll check is 4, but notice 4 is already on our list, so we know we're done. And then we look for our goal. We want to find the numbers that will combine to give us negative 8. So we can start checking through our list by adding and subtracting the pairs. If we add 1 and 12, we get 13. If we subtract 1 and 12, we get 11. If we add 2 and 6, we get 8. If we subtract 2 and 6, we get 4. Now, wait a second. 8, that's the number that we want, or very close to it. We really wanted negative 8. But remember, the next step is to play around with the signs a little bit. So here we go. 2 plus 6 is 8, but we want a negative 8. Negative 2 plus 6, well, that gives us 4. That didn't work. What about 2 minus 6? That gives us negative 4. Not what we want. Our last combination is if both numbers are negative. Negative 2 minus 6, and that's the negative 8 that we're looking for. So when we write our expression in factored form, the two numbers that we'll use are negative 2 and negative 6. Let's check one last time. We have x minus 2 times x minus 6. So x times x gives us x squared. Now x times negative 6, that's negative 6x. Negative 2 times x, that's negative 2x. And negative 2 times negative 6 gives us positive 12. There's those like terms in the middle again. We can combine them, and we'll do it carefully. So we can bring down the x squared, and then a negative 6 minus 2. Remember, same sign, add the numbers, keep the sign. So that gives us a negative 8x, and bring down the 12. This is exactly our original, so we factored correctly. That wraps up our first lesson on factoring quadratic trinomials, which means now you're ready to practice these kinds of questions on your own. Have a beautiful day.